In task or job problems, we look at tasks that are straightforward and whose completion rate is predictable. Here's an example. John can paint a room by himself in 3 hours, and Phil can do it alone in 6 hours. How many hours will it take them to do it together? Usually, these are tasks involving repetitious labor which can be done either by humans or by machines. Examples might be painting a room, copying or printing documents, addressing envelopes, and so forth. Here is the essential formula. 1 divided by total time equals 1 divided by time 1 plus 1 divided by time 2. Applying the formula directly, we assume time 1 is John's time and time 2 is Phil's. So we get this equation. 1 over x equals 1/3 plus 1/6. Notice that we put x in the denominator of the first fraction because that's the unknown quantity. But what does the equation mean? We know that John can do the job in 3 hours, so 1/3 represents the portion of the job he can do in 1 hour. That is, he can do 1/3 of the job in 1 hour. Phil then can do 1/6 of the job in 1 hour. And working together, they can do 1/3 plus 1/6 of the job in 1 hour. Let's solve the equation for x and continue our explanation. 1 over x equals 1/3 plus 1/6, which is equal to 2/6 plus 1/6, and that's equal to 3/6, and that's equal to 1/2. That is, 1 over x equals 1/2, so x equals 2. We conclude, therefore, that the formula is capturing the portion of the job that the two working together can accomplish in 1 hour. In this case, they get 1/2 of the job done in an hour. So working together, they can get the whole job done in 2 hours. Now let's change the numbers and see what happens. Suppose John can do the job in 3 hours and Phil in 4. So John equals 3 and Phil equals 4. Then we have 1 over x equals 1/3 plus 1/4. That's equal to 4/12 plus 3/12, which is equal to 7/12. 1 over x equals 7/12, so x equals 12/7. Therefore, the job will be done in 12/7, or 1 5/7 hours, when the two work together. Notice that we still just invert the two fractions, 1 over x and 7 over 12, to get the desired result, x equals 12/7. Here's another example which uses the formula a little differently. John can paint a room by himself in 3 hours, and John and Phil together can do the job in 1 7/8 hours. How long would it take Phil to paint the room by himself? Again, we use the formula, but this time we put the unknown value in a different place. We observe first of all that 1 7/8 is the same as 15/8, which inverted is 8/15. So 8/15 equals 1/3 plus 1 over x. Thus, 8/15 minus 1/3 equals 1 over x. And 8/15 minus 5/15 is equal to 3/15, and that's equal to 1/5. So 1/5 equals 1 over x. Therefore, 5 equals x. That is, Phil can paint the room by himself in 5 hours. The point of this example is to show that we use the formula as a tool to find the solution to the problem. In this case, we simply needed to know where to put the unknown value, the x, in order to properly solve the problem.